Okay, so we're gonna look like you said. Okay. So yes, our trig functions are based upon a triangle. Specifically, what type of triangle? A right triangle. So if this was our theta, up until now we've talked about sine, cosine, and tangent. So what did we say that sine equals? Opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And the tangent is opposite over adjacent. So then our three new functions are going to be cosecant, secant, and cotangent. And these are actually the reciprocals of our three main trig functions. What is a reciprocal? What do you mean by opposite? Yes, so it's the flip or the reverse fraction, yes? So cosecant is going to be the reciprocal of sine. So if it's the reciprocal, what is it going to equal? Hypotenuse over opposite. And then if secant is the reciprocal of cosine, what is it going to be? Hypotenuse over adjacent. And then lastly, cotangent is the reciprocal of tangent, so we get adjacent over hypotenuse. Now remember that we do have like abbreviations for these. So we have sine is sin of theta, cosine is cos of theta, and tangent is tan of theta. Likewise, we have abbreviations here for cosecant, because cos is already taken by cosine, it's actually csc of theta. Secant is sec of theta, and then cotangent is cot of theta. So really, once we've found our first three, it's pretty easy to find our next two, because we can just flip all of our fractions. The hardest part is going to be remembering which reciprocal goes with which main function. And just be careful, because notice that the sine and the cosecant go together and the cosine and the secant go together. Because a lot of people want the s's and the c's to match up, and they don't. Questions on any of that stuff? Yes, no, maybe? Alright, so let's look at this example. So it says use the figure to find the values of the 6 trig functions of theta. So it gives me a triangle, and it gives me 2 of my legs as 3 and 4. Can anyone tell me what my last leg or the hypotenuse is? How do we know that it's 5? The 3, 4, 5 thingy. Yes, it is a 3, 4, 5 triangle, which is one of our special ratios. Does anybody know any of our other ratios? Yeah. What is it? Well, that would be the angles. Well, like the ratios of the sides. What? 5, 7, 21,
gonna say 365.
That's not right. That's alright. 345 is the one that we use the most often. However, if we didn't remember that it was a 345 triangle, what would we use instead?
A squared plus B squared.
Which is called our Pythagorean theorem. Now you use A's, B's, and C's, right? I could have just as easily used X, Y's, and Z's, smiley faces, hearts, and stars, right? It doesn't really matter. It's one like squared plus the other like squared equals the hypotenuse squared. And that's the big thing, is that your C or whatever is by itself, not being added, always has to be your hypotenuse squared. Does that make sense? Other than that, it doesn't really matter which one you label as A, B, and C. Okay? So if we did that, notice we would have 9 plus 16 equals C squared, which is 25 equals C squared. So C does indeed equal 5. Yay! So then it asks us to find our 6 trig functions this time. So let's start with the 3 that we know. So what is sine going to be of this function? It's going to be opposite of my theta. So 4 over my hypotenuse, which we decided was 5. Okay, and then we have cosine is going to be 3 over 5, because it's adjacent over hypotenuse. And then lastly, tangent, going to be 4 over 3. Yep, and so from there we can just flip all of our fractions or find the reciprocal of each of our fractions, and those are going to give us our 3 reciprocal functions. So we have 5 fourths, 5 thirds, and 3 fourths. That's it. Woo. The only difference, or the only thing that might be a little bit different, is sometimes we won't have as nice of numbers. So if we end up with things with square roots in them, just remember that if we flip that fraction and we get square roots in our denominator, you do need to rationalize. So like if sine was the square root of 3 and I flipped it to be 1 over the square root of 3, I would need to rationalize that to be the square root of 3 over 3. Because there are some like that in your homework. And we're all big kids now, so I do expect you to rationalize any of your answers. Y'all okay with that? Questions over our 6 trig functions. Now, the big place that our trig functions come up, right? That's the reason why we learn them, why they're so important, is because we can use them to help us solve problems that involve triangles. We're talking about application or word problems. So it says a surveyor is standing 115 feet from the base of the Washington Monument. We're actually going to draw our figure. The surveyor measures the angle of elevation to the top of the monument at 78.3 degrees. How tall is the Washington Monument? So there is a reason that Mrs. Bennett teaches math and not art. So I'm going to draw you a picture, and we're all going to realize that this is the extent of my artistic ability. So you'll just have to deal with it. All right, so we have our surveyor. Like I said, the extent of my artistic ability right there. Okay, and we said that he is 115 feet away from the Washington Monument. So we know that is 115 feet. From the scale. And then it also tells us that we know what the angle of elevation. So we know that we're looking to the top of the monument, and it tells us that we want to label the angle of elevation as 78.3 degrees. So what or which angle would that be? It is going to be our theta, but specifically for our triangle, okay, it's going to be which bottom right? Hopefully we say no. That's our right triangle, or right angle, right? Or we have our top or our bottom end. I agree. It's going to be our bottom left. How would I describe the top angle? It would be the angle of almost starts with a D. Nope. Their angle of depression. We have an angle of elevation, which means that we're going up. Angle of depression, which means we're going down. Yes? No? Maybe? Okay. So then from there, it's asking us for the height of the Washington Monument, which is going to be that one right there. So we have a right triangle, we have angles and sides, which usually informs us that we're going to use a trig function. Okay, which trig function do we want to use? Does it matter? Could we use any of our trig functions? So we could technically use any of our trig functions because we know the angle. So we could find sine, cosine, or tangent of any of those angles. However, notice that we are looking for the opposite side to that angle, yes? And we have the adjacent side to that angle. So if we wanted to find or use sine or cosine, we would have to find that hypotenuse first by using sine and cosine of that angle. And when we do that, that means that we would actually have to round or break off our decimal. So it's not going to be quite as accurate. So if there is a way to only use the information given, that's the route we want to go because it keeps our answer more accurate. Sometimes there won't be a way to do that. In this case, there is. So which of our trig functions uses opposite and adjacent? Tangent. So I want to use tangent of 78.3 degrees. So what is our opposite side? X. What's our adjacent side? Okay, so then how do we solve for X? How do we solve for X? Ish. I mean, I don't like the term cross multiply because people use it to mean different things. But we could multiply by 150. Okay, and then from there we can use our handy dandy calculator. You want to make sure that your calculator is in degree mode, otherwise you're going to get a really funky answer. We're going to plug that in, and we're going to round it to 3 decimal places. What do we get? Three, 1, 4.
How do you change it from degree to degree?
Okay, what is my unit on this? Feet. Alright, so that would be like. And the Washington Monument is actually 555 feet tall. So there you go, it's pretty accurate. So our surveyor did a pretty good job surveying. Good job, you know. Questions on this one? Yes, no, maybe? Alright. So this time it says a historic lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle theta between the bike path and the walkway as illustrated in the figure. So this time our theta is this upper right-hand corner angle. And again, this time we're given two sides and we want to find the angle. So which trig function might we use? Sine, because we have opposite and hypotenuse. So we know that sine of theta equals what? 200 over 400, which reduces to 1/2, which should look vaguely familiar, because that's one of our options for sine on our unit circle. So at what angle does sine equal 1/2? So at 90, remember our point is 0 or 1. So cosine is 0, sine is 1. The other one. It'd be 30 degrees. Okay? Remember, your sine is your y value, or your second value. Is that the only spot on my unit circle? It also equals 1/2 in my second quadrant as well, right? Because sine is positive in my second quadrant. But why can't I use that angle instead? It's bigger than 90.
It's going to add up to be.
And why is that important?
Because inside I know.
Yes, and then what else does it tell us?
That's a key, so it can't be
There you go. So we know that our theta has to equal 30 degrees. And that would be our answer. Yes? All right. I want you to try one on your own. This time we're talking about the height of a mountain. All right, so which trig function do we want to try and use this time? We said sine, do we agree?
Yeah.
Okay, because which letter are we looking for?
Okay.
Little a, yes? That's going to be our height of our second mountain. So we would want to set it up. Sine of what? 27 degrees is equal to A over 25,000. So what do we do to solve for A?
We
Multiply by 25,000. Plug all of that into our calculator. What do we get that A is?
11,349.7.
Okay, is that our final answer? Yes, we do have to add that 5,000 to it because it asks us what the entire height is, not just how much taller it is. So for our final height, we would have to take A and add 5,000, which is going to give us 16,349.762 what? Feet. be our final answer. So be careful on ones that ask you to like basically take your answer and do something with it. So you'll see those a lot on like the ACT as well. So don't just stop once you find that first part. Make sure that that's the final answer that you want. All right. So then let's look at one last example together. So it says at a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees, whereas the angle of elevation to the top is 53 degrees, as shown in the figure. Find the height S of the smokestack alone. What do we want to do?
For the 300 one and the 53 one. Subtract.
So I could find the height of the entire thing. So let's label that as, say, X. Yes? And then if we subtract it off, just the A portion, that will give us the S portion. So how many triangles are we dealing with? 2. We have our smaller triangle, which is the one that has 35 degrees. Then we have our larger triangle, which is the one that has 53 degrees. Now we do end up using the same trig function for both of them. So what trig function do we want to use? Tangent. Because we have adjacent, we're looking for opposite. Agreed? Okay. So let's set it up with our first smaller triangle first. So we have tangent of 35 degrees equals what? What is it? It is not X. It is A. So it is A over 200. Which means what does A equal? 200 times tangent of 35. And I'm going to leave my answer like that for right now, because since we're going to be using that to find another piece, I don't want to plug it into my calculator and round just yet. Because if I use a rounded answer, it compounds my rounding error. So then we want to find X. So how would we find X? Tangent of our big angle. 53 degrees equals X this time, because I'm talking about the big 1 over 200. So again, we multiply by 200. So we get 200 times tangent of 53 degrees. So what are we actually trying to find here? Which is which variable? We want to find S. And yes, we would take our X and subtract our A. So we get 200 tangent of 53 degrees minus 200 times tangent of 35 degrees. So S is approximately
125.37.
125.7. And what unit are we in? Feet again. And that would be our answer. Questions on that?